Hello everyone. So this video lesson will talk about a lesson about composition of functions. This lesson is found in module 3.2 of General Mathematics, quarter 1. Of course, at the end of this video lesson, you are expected to perform composition of functions. To begin, let's find the output for each machine below. So we have here machine A with this function f of x is equal to x plus 4. And machine B with the function g of x is equal to 8x minus 5. So below each machine is a table of values wherein the first row is the input x. So this values must be the one to replace the x variable on our function. So when x equals 0 in this machine, we can have f of 0 equals 0 plus 4, and that is equal to 4. So we write 4 here. Then if x equals 1, we have here f of 1 equals 1 plus 4, and that is equal to 5. If x equals 2, we have here f of 2 is equal to 2 plus 4, that is equal to 6. So as you can see, we just replace the x variable with the number we have here on the first row of this table. So now let's proceed to x equals 3. So we can have f of 3 is equal to 3 plus 4, and that is equal to 7. So we write 7 here. Then at x equals 4, we have f of 4 equals 4 plus 4, that is equal to 8. Okay? So now let's move on to the next machine having this function. So when x equals 0, using this function, we have g of 0, okay? The x variable must be replaced with the number we have above, is equal to 8 times 0 minus 5. And 8 times 0 is 0. 0 minus 5, that is equal to negative 5. Okay, we write here negative 5. When x equals 1, we have here g of 1 equals 8 times 1 minus 5. 8 times 1 is 8. And 8 minus 5, that is equal to 3. So we write 3 in this table. Then at x equals 2, we have g of 2 is equal to 8 times 2 minus 5. 8 times 2, that is equal to 16. 16 minus 5, that is 11. For x equals 3, we have g of 3 equals 8 times 3 minus 5. And 8 times 3 is 24. 24 minus 5, that is equal to 19. So you write 19 on that table. Then lastly, at x equals 4, we have g of 4 is equal to 8 times 4 minus 5. 8 times 4 is 32. 32 minus 5, that is 27. Okay? So with that, we already recall the concept of how to evaluate functions. Now, let's move forward. This time, let's connect machine A to machine B such that the output of machine A becomes the input. Okay? If this is the output of machine A, this will be the input for machine B. With that, we have here a table of values wherein the first row is the x variable, the input for machine A, and the second row is the output of machine A and will become the input for machine B. So the values here are just gotten from the previous slides we have a while ago. So this time we're gonna have to work with this function g of x equals 8x minus 5. So when x equals 4, using that function, we have here g of 4 is equal to 8 times 4 minus 5, which is equal also to 32 minus 5, which is 27. Then at x equals 5, we have here g of 5 is equal to 8 times 5 minus 5, that is equal to 40. 40 minus 5 is 35. And then at x equals 6, we have here g of 6 is equal to 8 times 6 minus 5. 8 times 6, that is 48. Then minus 5, that is 43. And then at x equals 7, we have g of 7 equals 8 times 7 minus 5. 8 times 7 is 56, then minus 5, that is equal to 51. And finally, at x equals 8, we have here g of 8 is equal to 8 times 8 minus 5. 8 times 8 is 64. Then 64 minus 5, that is equal to 59. So we write here 59. So the process that we did illustrates the process of finding the composition of function. Okay? To define composition of functions, if f and g be functions, then the composite function denoted by f circle g is the function defined by f circle g of x is equal to f of g of x. Then this process of obtaining a composite function is called the function composition or composition of functions. So that is the definition. Now, let's move on to some illustrative examples for you to understand it better. Now we have here three given functions. F of x equals 2x minus 3, p of x equals 5x plus 8, and r of x equals 2x squared plus 3x minus 1. So we have to solve this example. We have here solve for f circle r of x. So we have to find the composition of f of r. So this composition. So first thing to do is to define this composition. We have here f circle r of x is equal to f of r of x. And this one will be put on the left side of our second equation. So we have here f of r of x is equal to 2x minus 3. So we are going to write or put down the function of the letter, the first letter that we have on the left side of the equation. Since this is f, then we have to take its function and write it here on the right side of the equation. And then after that, we are going to write here the value or the function of r of x. So that is 2x squared plus 3x minus 1. So this is the function of r of x, which is written here above. Okay, and the function on the right side is that belongs to f of x, which is 2x minus 3. So what letter comes first on the left side of the equation? We have your f. Then we are going to write its corresponding function on the right side of the said equation. Okay, does it make it clear? So with that, having this value, having this function, we are going to put this and replace. Okay, replace x as this polynomial with this polynomial. So we have here f of 2x squared plus 3x minus 1 is equal to 2. Then with x, we're going to replace that with this polynomial, that is times the quantity of 2x squared plus 3x minus 1 minus 3. Okay, we are just replacing the value of x with the polynomial here we have on the left side of the equation. And then with that, we're going to simplify. Let's distribute 2 to each term inside this parenthesis or in this polynomial. That is 2 times 2x squared is equal to 4x squared. 2 times 3x, that is 6x. 2 times negative 1, that is negative 2, and copy negative 3. Then we are going to combine the like terms. Since 4x squared and 6x has no other like terms, then we are going to bring them down. Copy them. 4x squared plus 6x. Then we have to combine negative 2 and negative 3. So that is negative 2 minus 3. That is equal to negative 5. And therefore, f circle r of x is equal to 4x squared plus 6x minus 5. So this is now the composition of the function given in this example. We are going to solve for that. Okay, that is the answer for what is being asked. Okay, now let's proceed to another example. Example number 2, solve f circle p of x. So first thing to do is to define the composition. We have here f circle p of x. Okay, take note, this can be read as circle. Okay, take note of that. So first thing to do is to copy that one here. Then we equate that to its corresponding expression, which is f of p of x, which defines composition of function. Then we write this on the left side of the next equation. We have here f of p of x is equal to, since f is the first variable on the left side of this equation, we're going to take its corresponding function, which is 2x minus 3. So we write here 2x minus 3 after the equal sign. And then we're going to write also the value of p of x, the function, which is 5x plus 8. We have here f of 5x plus 8 is equal to 2x minus 3. And then we're going to substitute this to the value of x on the right side of the equation. So we have f of 5x plus 8 is equal to 2 times 5x plus 8 minus 3. Then we distribute 2 to each term inside the parenthesis. 2 times 5x, that is 10x. 2 times 8, that is positive 16. Then minus 3. Then we combine the like terms. So bring down 10x. Then we are going to combine this. Positive 16 and negative 3, that is 16 minus 3, that is equal to 13. And therefore, F circle P of x is equal to 10x plus 13. So this is the final answer. Example number 3, solve for P circle R of x. So first thing to do is to define again the composition. We have to copy that, given that equate that to P of R of x. Then right here on the left side of the next equation equals, since P is the first variable on the left side, we are going to take its corresponding function value, which is 5x plus 8. So equals 5x plus 8. Then we are going to write down or to input the value of R of x, its function. That is P of 2x squared plus 3x minus 1 is equal to 5x plus 8. Then we are going to substitute that in this variable, which is x. So we have here equals 5 times the quantity 2x squared plus 3x minus 1 plus 8. Then we distribute 5 on each term inside this. Okay, so 5 times 2x squared, that is 10x squared. 5 times 3x, that is 15x positive. 5 times negative 1, that is negative 5. Then bring down plus 18. We combine the like terms. So that is, bring down 10x squared and 15x. Then negative 5 plus 8, that is positive 3. And therefore, P circle R of x is equal to 10x squared plus 15x plus 3. So that is the final answer. Example number 4, we have to solve for P circle F of x. Okay, first thing to do is to define its composition, that is equal to P of F of x. Then we are going to write this on the left side of the equation, the next equation. Then we are going to take the function of P of x, which is 5x plus 8. Then we write that on the right side of this equation. Then we are going to input again this, the value of this function, f of x, that is 2x minus 3. So we write here 2x minus 3. Then we substitute this binomial to the x variable on the right side of the equation. So we have here 5 times the quantity 2x minus 3 plus 8. Then we distribute 5 on each term on the binomial. So we have 5 times 2x, that is 10x. 5 times negative 3, that is negative 15. And bring down plus 8. Then we combine the like terms, bring down 10x. Combine negative 15 and 8. So negative 15 plus 8, that is positive 3. And therefore, P circle F of x is equal to 10x plus 3. All right. Now let's move on to example number 5. Solve for R circle P of x. So define it, copy that, and equate that to R of P of x. Then write R P of x here, R of P of x. Then the function of R of x is 2x squared plus 3x minus 1. Then we also define the function of P of x. We have to write that here. So that is 5x plus 8. Then we are going to substitute this value to each x variable on the right side of the equation. So we have here 2 times the quantity of 5x plus 8 raised to the second power plus 3 times the quantity of 5x plus 8 minus 1. Then we're going to, okay, so distribute 2 on each term and 3 on each term. Okay? So we have here 2 times 5x, that is 10x. 2 times 8, that is 16. Okay? Then 3 times 5x, that is 15x. Then 3 times 8, that is 24. Then bring down minus 1. And then with this, since it has an exponent, we're going to simplify it, expand. So that is equal to 100x squared plus 320x plus 256 plus 15, bring down that, then plus 24 minus 1. Then we're going to combine the like terms. Okay, since 100x squared has no like terms, we bring it down. Then we combine 320x and 15x, that is equal to positive 335x. Then combine 256, 24, and negative 1. Okay, 256 plus 24 minus 1, that is equal to 200. 59. Therefore, our circle P of x is equal to 100x squared plus 335x plus 259. And here it ends our discussion for composition of functions. I hope you follow the steps on how to do it, and I hope you learned something from me. And thank you so much for your time. See you on the next video lesson. Thank you so much.